Hey everybody, today we're going to talk about R packages. We're going to build our first R package based on the whole game chapter number 2 of the R packages book. Think of this as a minimally viable package that's going to work, but it's not going to really do anything all that useful. So if you follow and complete all the sections in the book, which is again a minimally viable package, you're going to end up with something that looks like this. This R package is not going to do anything fancy. What is it going to do? It's going to take, it has two functions only. The first one, it takes two vectors of factors and creates an fbind or factor bind function that combines them into a single vector of factors. The other function is that it's going to take a series of random letters right here.
Just a moment.
And it's going to compute.
Okay, I found this on the web for random letters. Check it out.
All right, Siri, I don't need you right now. I'm going to turn you
I'm
off.
not sure I understand.
Okay. It's going to return a tibble of a count of each of the letters. Also, I've added a toy data set, toy data. Again, this is going to be the product of having completed Chapter 2 of the whole game book. So folks, before you do this week's mini project, go through Chapter 2. It gives you the minimally viable set of tools you need to build an R package. But let's supplement the notes a little bit with a chalk talk. So R packages. Package components. The first component is a folder called data. A folder, the data folder saves data preloaded in package. So for example, if you want your data set to if you want your package to include a data set, it gets saved in there. The next folder, data-raw. This is where you save raw data sets that you want to include in your package. So it is the raw version, example.csv files of the data in data folder. So the idea is, if you have a CSV that you want to include in the R package, you should save it in here, and then we'll see a way to have that automatically loaded into the data folder. Next, man. This is where the help files get saved. But the nice thing is, we don't ever actually have to work directly with help files. We're going to use something called the Roxygen 2 package to make documenting, creating help files easier. So again, this folder here, do not edit. We're not going to edit that directly. Next, we have the R folder. The R folder is going to save the source code for all functions in package, PKG. So for example, there is the group by function in dplyr the source code for that, or the source R code, will be saved in R. That's one thing that'll be included there. It'll be the Roxygen 2 code to create all help files. Whoops. Both functions and data sets. So for example, the group by function in dplyr will have a help file, but also the empty cars data set will also have help files. Next, tests. This is for unit testing of package, meaning you want to generally write tests that make sure that your package work the way they should. We're going to punt on this for now and talk about tests later. Next, readme.rmd. This is a file that is the source code of what you see on GitHub. So if I go back over here, when you visit a package homepage, notice how there is a file called readme.md. That is for readme.markdown and is the welcome page of a particular repo. Any repo should have a nicely documented and nicely written help page so users can quickly understand what it is you need to do. Whoops, so let me go back over here. Readme.rmd is the source code of readme welcome page. But the idea is, after you knit this, out comes readme.md. You are not going to edit this file. Do not edit readme.md. Rather, you're going to edit readme.rmarkdown so that you can incorporate R code, but then what goes on the web page is going to be readme.md. So think of readme.rmd as sort of the root file, and this is the input file, if you will, and this is the output file. Next, description. This is a key file in any R package. It gives package info. For example, the authors. What other packages you need to install. Other packages are required. And other information like that. All right, there are some other files in here, but I think that in terms of describing them and writing them out, this is all we need right now. So let's go back to RStudio and look at these files and folders one by one. Again, this is what you'll end up with if you complete chapter 2 in the book. But I've also done something from, what chapter is it? I've also added a little bit, I've done a little bit more. Where is it? I've done also a little bit of chapter 14 to add a data set to the package. So let's jump into data-raw. Data-raw has a file called dataset.r. This is where we create or you load, for example, CSVs or create data sets that you want your package to include. But then, by running the useData function from the useThis package, it's going to create toy data for use in the package. And where does this get saved? This gets saved in the data folder. .rda is a specialized compressed file format that now we can use in this package. So for example, if I restart R and I type library foo factors and I type toy data, this data is ready to go. Next, foo factors. Man, these are the help files for the different functions. So for example, if I type $fbind, it gives you the help file. Now folks, if you want people to use your package, it's important to give informative help files. But notice here, it says, this document is README only. It is generated from fbind.r. So remember what I said, we are not going to directly edit these files, but still you need these files to create or install the R package. So again, what's in the man folder or manual is not going to be something you will edit. Instead, here is the .r folder. So for example, it says it's generated from fbind.r. Let's click on that file. It gives you a simple way, for example, this is where on top you write the documentation or the help file for the package, and down here is the actual code for the function. So let's go back to that help file. See how the various components of this file line up with the various components of the help file. And then down here, we have the actual function. Let's take a look at another one. fcount is a different function. Okay, so we have a different title, different inputs and stuff. Let's take a look at fcount. See how they line up. Now, one more. You also want to write help files for your data. So this is from chapter, I think it was, what was it again? Chapter 14. This is where you write the help file for data sets. So, for example, if I do toy data, interesting. I'm not quite sure why this isn't working. I may have to fix this. I know what I forgot to do. Document toy data. I've neglected a step here because even though I've created this particular Roxygen code for the this data set, for some reason the help file doesn't exist. So I must have neglected one particular step from chapter 14. Let's move on. License and .md and license are where you set the license of usage of this package. Next up, we have the gitignore file. Anything that you write in the gitignore file will not be synced with GitHub. So for example, for these five files here, even though they are in my, my RStudio project, they are not being synced with GitHub. And I should note that because they start with a dot, they are considered a hidden file. We can show hidden files by clicking on More, Show Hidden Files. There we go, .rproj_user, so on and so forth. These are files that will not be synced on GitHub. We have the RStudio project file. We have the output of readme.md, but remember, you want to be only editing readme.md. So they even put a note here. Readme.md is generated from that. Please edit that file. In other words, do not edit readme.md, but rather edit this file. And the contents of this file match up with what you see on GitHub. All right, almost done. Next, rbuildignore. These are files and folders that you don't want to include when building or installing the package. So for example, our packages don't want to see RStudio project files. Also, our packages don't technically have data.raw folders. So what this is saying over here is don't use these particular files when building the package. So if you have a file in here that you want to include, but you want the package to ignore when installing, that is a thing to do, is to add it in our build ignore. Next, description. This is a really important one right here. This is where you give the package name, a description of what it does, where you set the version numbers. You determine, as you did in Mini Project 1, who the authors and creators are, a description, a license. Also, what other packages must be installed for this package to work. And notice also how it depends on our version greater than 2.10. So for example, if you want, let me see what version of 4cats library 4cats session info. Where is it? If you want people to use version 0.5.0 or greater in order to make sure that you have access to the same functions, you would add something like this. This will require people to update their version of the 4cats package if it is lower than 0.5.0. Great. Last but not least, namespace. Do not edit this file. Don't worry about it. All right. The last thing. Using what was in chapter 2 of the book, the way you build or install the package. DevTools. Install. What this is going to do is, if you've made changes to the package and you want to reinstall it locally, meaning reinstall the version of the package on your computer, you do install. So it's a good idea to run this quite often to make sure that all your little changes are all still working. The other important component, check. What this does is it makes sure, oh, interesting. Toy data is not an exported object from namespace foo factors. Let me see if I can figure out how to quickly add the help file for that data set. Exported data set, use this data raw, document, export a data set, use this, use data, data.raw. Okay, how do you document this? Again, I am learning too because these instructions have changed. Where was it? Document, down here. Okay, document, let's run that. Toy data is not an exported object. Okay, folks, well, you know what? Let me get back to you on that dataset part, and for now, we're going to delete this. All right, so we'll reinstall this package. And we'll run the check. So for example, what this just caught is, it said, hey, you have a data set called toy data, but you didn't document it. So what it's saying to me is that, hey, you better document that. Now, unfortunately, I don't remember off the fly how to do that, but this is a good lesson in checking that your package works. So even though there are a couple of notes over here, and you can Google these things, the key things are that you have 0 errors and 0 warnings. So folks, before you make a pull request, it is important to ensure that your package has 0 errors and 0 warnings. That way, if somebody else tries to use it, they won't have any errors. Let's go back to our notes. Building / installing and testing / checking package. It is important to do this, folks. Number one, I should say first you do library DevTools. All right. Number one. Number two. Number one, the way you do that is with install. Do this often. Make sure that your package works by installing it. Number two, check. You generally want to do that before any major pull requests. So do this, maybe not as often as install, but do this often enough so that errors and warnings don't snowball. All right, and what I mean by snowball is accumulate. And the last thing I'm going to say, two ways to install a package. Number one, directly off GitHub. You can install a package directly off GitHub by, and let me go back to the computer here. Using DevTools install GitHub. That is one way to install a package directly off of a GitHub repository. Directly off GitHub using DevTools install GitHub. So for example, if you want to share this package with your friend and say, hey, come test out my package, well then you know what? Just have them use this function. But the other way is to upload it to CRAN. This has strict requirements. And what do I mean by CRAN? When I mean upload to CRAN, it's when you can install our packages directly from RStudio. So for example, packages, install. ggplot2 is available and you can install it from CRAN. But I'm going to guess foo factors. You see, foo factors was not yet uploaded on CRAN. Therefore, you can't install it directly in RStudio. You have to install it from GitHub. I think that's plenty for now, and that should be enough to get you started. But one thing I'm still going to need to address is how do you get a particular dataset's help file to show up in here? I'll push those changes in a minute. Thank you.